There, algebra. There we go. Still having issues with this camera. I don't like where it is because when I look at my face, which is generally what I look at when I talk to you guys, I'm looking to the side. If I look at the camera, then I'm looking at you. Like if I look right here at my camera, I'm looking at you, but I always look at my face when I talk, which is weird, I know, but whatever. All right, today's lesson actually has to do with absolute value, which is very cool. So we're going to learn a little bit of neat stuff today. Let me get to one thing. Sorry. So we are going to that's amazing. I did not write that slow. Analyze. Okay, actually let me do it this way. Hold on. Okay, so it's going again. So today what we're doing is we're learning how to analyze and describe features of a scatter plot that relates guesses and absolute value. So the first thing I actually want you guys to do is look at this jar of units. This is something we use in lower level math to teach counting and such. So look at this jar and guess how many of those little pegs you think are in that jar. So if you think about it, I don't know, 1, 2, 3, maybe there's 6 in that bottom level. 1, 2, 3, 4, 5, 6, 7, 8, 9. That'd be about 54. So I'm going to guess 54. And if we were in the classroom, we'd get all of you to give your best guess. And unfortunately, we can't do that. So we're just guessing willy-nilly. So we're actually going to use this to compute absolute guessing errors using the class data collected. Absolute guessing errors. And then we're going to plot it in the next activity. So absolute errors are calculated a bunch of different ways. All right? We're going to do it by hand. And what we would do is put the guess here and then the absolute guessing error there. And to do that, you need to know the actual number. And I got the actual number is 47. And I think I guessed 54, so we'll put that as one of them. And then the absolute guessing error just means the difference between 47 and 54. So that would be 7. And by absolute, they all have to be positive. Okay? So they all have to be positive. All right, I'm going to push pause and fill in some more data, and then we'll go get back together again. All right, so actually I found the data here that we can use so that I don't have to write all of those things in there. Turn on the pen. That's wonky. Oh. So here we have all of the guesses. 1, 2, 3, 4, 5, 6, 7, 14, 15, 16, 17, 18, 19, 20. So 20 guesses, like 20 students got together and guessed how many little pegs are in that jar. All right, and then the absolute guessing error. So the answer was 47. So it's just the difference. And by absolute, we mean always positive. So this is the absolute guessing error. All right, now what are we going to do with that? So before this lesson, you were asked to guess the number of objects in a jar. The guesses of all the students have been collected. Your teacher will share the data and reveal the actual number of the objects in the jar. Use that number to calculate the absolute guessing error of each guess, how far the guess is from the actual number, and suppose the actual number of objects is 100. All right, we're not doing that. Oh, but if we did, if the actual was 100, they're teaching you how to do the absolute guessing error. If your guess is 75, the guessing error is 25 because it's 25 away. If the guess is 110, the absolute guessing error is 10. So it doesn't matter if you guess above or below, you're just finding the absolute guessing error, which is the distance from the actual number to your guess, and it's always positive. Record the absolute guessing error of at least 12 guesses in Table A of the handout from your teacher, which we didn't get, but this is what we have here, and this is a handout I would be giving to you. So you'd fill in all the guesses and all the absolute guessing errors. and that's where we're leaving that right now. We're not going to plot it quite yet. All right, we're going to use this though. Do not worry. All right, now, here we go. Plotting the guesses. Refer to the table you completed in the warm-up, which shows your class's guesses and absolute guessing errors. Plot at least 12 pairs of values from your table on the coordinate plane on the handout or elsewhere as directed by your teacher. Write down 1 or 2 other observations about the completed scatter plot. Okay, hold on a second. Let's do that. All right, so here are all of the points plotted. So, for instance, somebody else guessed 54, which is about right here, and the difference between 54 and 47 is the absolute guessing error. So each value, okay, and the absolute guessing error. So somebody guessed 40, the difference there is 7. Someone guessed 32. No one guessed 32. Somebody guessed, that's 36, and the difference there is 11. So here are the absolute guessing errors plotted. Now, what do we see here? Like, what are some observations? If I just highlight this down, and highlight this up, oh, for goodness sakes, that is terrible. I'm so sorry. Let's see if we can insert, oh gosh. Insert a line, and we're going to insert another line. Okay, some of you may recognize what this looks like, what type of function it is, what type of graph, what type of parent, etc. But we'll talk about that in a minute. So right now, what do you notice? What did I say the solution was? 47. So this being totally random, if we did this with another jar of something, if we did this with, I don't know, some jelly beans, some M&Ms, whatever it is, if I knew exactly how many jelly beans were in a jar and I had the whole class guess, and maybe the whole school guess, etc., it will always, always, always give us an absolute value function that ends up revealing what the real number is. It's really, really cool. All right, let's see what else we're supposed to be doing for that. Write down observations. Cool. Is the absolute guessing error a function of the guess? Explain how you know. Okay. Yes, it is. So the guessing error depends on the guess. If we graph this, we've learned, oh gosh, can't spell. When we graph, we know that this is my independent variable and this is my dependent variable. So if you look at that graph right up here, dependent is my absolute guessing error, and it depends on the guess, which is my independent. So the absolute guessing error depends on the guess. So the absolute guessing error is a function of the guess because the absolute guessing error depends on the guess. All right, so oops, try again. Earlier you guessed a number of objects in a container and then your teacher told you the actual number. Suppose your teacher made a mistake about the number of objects in the jar and would like to correct it. The actual number of objects in the jar, let's see what we said here because I'll have a pre-made graph to use, which is super duper helpful. Here we go. So the absolute number is 50. All right, so find the new absolute guessing errors based on this new information. Record the errors in Table B of the handout, which we're not doing Table B. So our original guess, our original actual is 47, and the new one is 50. So what's going to happen to our graph? All right, let's see if I can just show you without cutting and pasting it. All right, so the actual was 50. So our absolute guessing error, this one went up by 3. This one went, like, increased by 3, increased by 6. If you look at the original, which is right here. Yep. Sorry, where were we? Here we increase, like, this is a plus 3, plus 3, plus 3. Here, 59 was the guess, which was above. So we have 9. So I think that's going to be a minus 3 from our original. 12. So minus 3 is 9. So if we guessed high, we got a minus 3. If we guessed low, we got a plus 3. We guessed high, etc. All right, so the absolute guessing errors went up for many of the guesses, but some went down, but still no negative. You're not going to get any negative. All right, so our answer, if we see we have a graph here. Oh, there's no graph. So what's going to happen, let's go back to the graph. So our V, let's do a red pen, is going to end up 48, 49, 50. This is 52. So 50 is going to be about here. So everything is going to shift, and I think I can just grab this. I don't want text mode. I do want to be able to grab it though. Yeah. So our V, our absolute value function, is just shifting 3 to the right. That's it. All right, because we guessed high on a few and low on a few, we definitely are going to shift by 3 values. Let's see, is there anything else I need to make sure? Okay, technically, if we did this correctly, our slope would increase. I don't know if I can show that here. Yeah, if I plotted everything correctly, our slopes would be a little bit tighter too. Scatter plot would still form a V shape with the 2 lines meeting at 50, 0. Okay, technically it would have to go all the way down to the 50. I didn't draw those lines very well. So to find the output, subtract 50 from the input and take the absolute value. So yeah, that's what we were doing. All right, so sort of a weird lesson today, but important anyways. Oh, we didn't answer this last one. So can you write a rule for finding the output, the absolute guessing error, given an input? So really, to find the output, we would do absolute value, input minus 50. Or you could do 50 minus input. It does not matter as long as you take the absolute value of it. That would be my output. That's my rule. All right, and we're going to stop for now. Good job.